Hey, boys and girls. Nice to see you online. Welcome to your distance learning video. We're learning about congruent triangles today. So you just need to grab your definitions page and you can pause this. This is at your own pace. So you can pause this and take as much time as you need. I'll just be here waiting. All right. So on your definitions page, this is number 51. We only have one definition today. Let me move this up a little bit. Oh my goodness. Okay. Move this up to the middle. All right. So we are looking at congruent triangles, and they are triangles that have the same size and the same shape. All corresponding sides and angles are congruent. So go ahead and write that down and draw a picture. They don't have to be perfect because we're going to use some tick marks to show what's congruent, and then we're going to write a congruent statement. So it's really important that you know how to do that. All right, so I'm going to grab a pen, and when we look at these triangles, I'm going to tell you that angle A is congruent to angle X, and also angle B is congruent to angle Y, and angle C is congruent to angle Z. All right, so you can see the corresponding angles that are congruent to one another. And really, that's enough for you to understand which side should correspond to each other. You can see the same tick marks with A and C and X and Z. So AC is going to be congruent to XZ. And then we have AB is between the single and double angle tick mark. So that's the same as XY. I'm going to give it 3 over here. Lots of tick marks going on. All right, and then finally, the last two sides, CB, is going to be congruent to ZY. All right, so that's a lot of different things going on in the triangle. So you have 6 different things that are corresponding incongruent, 3 angles and 3 sides. So that's what we're working with is a definition of congruent triangles. Now, one thing that's super helpful is something called the congruent statement. So here, I'm going to give you a congruent statement. This is triangle, I'm just going to call it triangle ABC. You just go around and name it by its vertices. And I'm going to tell you that it's congruent to triangle XYZ. So here's the thing with the congruent statement, is that when you write the congruent statement, you notice that angle A comes first and angle X comes first, and they are the angles that are congruent. Pretty cool. Angle B I have second, and angle Y I have second, and angle B and Y are congruent. And then finally, C and Z are last, and those are congruent also. You can also look at the sides. So if you look at AB, the first 2 parts of this congruent triangle, it should line up with XY, the second, right? The first and second of the second one. So how you write the congruent statement, the first triangle dictates how the second triangle is going to be. So if I started this statement differently and I called it triangle CAB, triangle CAB, how about that? How would you complete the congruent statement? Take a second and think about that. Well, if you said ZXY, you're absolutely right. Because when you look at C, Z goes along with it. It's congruent to it. And A is congruent to X. And then B is congruent to Y. So the congruent statement helps you understand what's congruent in the triangle without all the tick marks. So look for congruent statements in your homework and in the book. We're going to move over into the book. We're going on to page 143. I've got a printout here. That's why mine is in black and white. Alrighty, so you're going to notice we're going into lesson 11-1, congruent triangles. And today we are going to use the fact that congruent triangles have congruent corresponding parts. Now we already defined it, so we're not going to spend a lot of time looking at the definition because you know what it is. And then we're going to determine unknown angle measures or side lengths in congruent triangles. So we've got this fun little storyline here with Jeff Carpenter. Springboard is kind of keeping us entertained here. I'm sorry, Greg Carpenter, my bad. So Greg Carpenter works for the Green Construction Company. I wonder if that's Mr. Green. Anybody have his teacher? The company is building a new recreation hall, and the roof of the hall will be supported by triangular trusses like the one shown below. Now, something that I find super interesting is that triangles are our strongest polygon. They're our smallest polygon, but they're super strong. And so you can see them everywhere. If you guys look underneath bridges, when you guys go over bridges in Florida, you're going to see lots of triangular supports either below or above the bridges. We don't have too many suspension bridges here in South Florida, but if you go up north, you will see some of them, and they're super cool to look at. Go into your roof. If your parent, go into your roof, don't go on your roof, sorry, go into your attic. If your parents will let you go into the attic, maybe get down some Christmas decorations, and you're gonna see trusses that look like this, and they are formed out of congruent triangles. So you can see a lot of different congruent triangles. Like I'll just highlight a couple. Here's one, and you can see symmetrically on the other side, that one is. And I want you to think about how important it is that they are congruent. They're exactly the same. Because imagine if this one is a little smaller, right? If this one is a little smaller, the roof would kind of come down a little bit. And then when it would rain, water would form right there. And in South Florida, it would turn to mold. And then you get a hole in your roof. An little animal would come in and water leaks. And it's just a mess. So super strong triangles, congruent triangles in the trusses are important. All right, so down here, it says each of the trusses contains a pair of congruent triangles. Greg's boss tells him that his first job will be to determine the side lengths and angle measures in the triangle that make up one of the trusses. So we're going to get back to Greg later on, but first we're going to go investigate these triangles in the trusses. So turn the page with me. So here's Greg. If I know that two triangles are congruent and I know the side lengths and angle measures in one triangle, do I have to measure all the sides and angles in the other triangle? Hold on one second. Just see if that made a difference. Greg begins by examining two triangles from a truss. According to the manufacturer, the two triangles are congruent. All right, so it says because the two triangles are congruent, can one triangle be mapped onto the other? So they're basically asking us, is there a way, is there a transformation that has been done where you could map ABC onto EFD? Do you see the reflection? Do you see that if we drew a line of reflection right here, we could fold the paper up and the angles and the sides would match onto each other? I hope so. All right, so if you see it, go ahead and put some tick marks on your triangles. You can do the sides or you can do the angles. I don't think you have to do all 6 parts. But yeah, so this is a reflection. And it's not really the y-axis because we don't have a coordinate plane, but we could say a reflection on a vertical line. Right, and let's go ahead and put those tick marks. I'm going to do it on the sides. So I can tell that AB corresponds and is congruent to ED, and BC corresponds and is congruent to FE, and AC to FD. Okay, so you're going to come down to number 2, and you're going to fill in the transformations that make sense. So it says, suppose you use a sequence of rigid motions to map triangle ABC to triangle DEF. Find the image of each of the following under the sequence of transformations. So AB would be mapped onto ED, segment ED, right? Put your little segment. Angle A would be mapped onto angle D. All right, so pause me for a second and fill in the rest, and then come back and let's check out the answers together. All right, so BC would be mapped onto FE. It doesn't matter if I said EF or FE. No, they're both the same segment, right? And angle B is mapped onto angle E. And side AC, segment AC is mapped onto FD. And then angle C is mapped onto angle F. Pretty simple stuff, right? I know you're digging it. All right, number 3, what is the relationship between segment AB and segment DE? What is the relationship between angle B and angle E? How do you know? So I would say they are congruent because they match and they have the same shape and the same size, right? So we're going to say AB is congruent to DE and angle B is congruent to angle E. Same shape and same size when we match them up. Okay, so because we already put the tick marks on this and because we've already gone through the definition of a triangle, you can come down here and this is going to explain this bottom part about the corresponding parts. So you can see if you might want to highlight this down here, when you write a congruent statement like triangle ABC is congruent to triangle DF, you write the vertices so the corresponding parts are in the same order. So it's giving you all 6 corresponding parts that are congruent, but you already know that because you're so smart. All right, next page. All right, so somewhat of a little problem here. I'd love for you to go ahead. Now, this is an example. Sorry, we're going to come down here. I'd love for you to go ahead and try this one because these are super easy. And yeah, it's super simple, right? So try these A and look what it gives you up here. It gives you the congruent statement. So you're not guessing. You know which parts are corresponding and congruent to each other. So find each of the following. You try it. Put me on pause. All right, so these are acclimated a little bit differently, but if you really look at it, this is like a 90-degree rotation, and you can see that S is congruent to Y, and you can check that out up here in the statement, right? Because S is in the middle and Y. So I'm going to just put a tick mark on these, and then I know R is congruent to X, and then Z to T, and I'll just leave them blank. So when it asks me for the measure of angle X corresponds to R, but I don't know any of those, so this is a not possible, right? So it says if possible. Don't you love it? So this is not possible. But if we knew one of those, we could find it. All right, so how about part B, YZ? YZ is this length here, and YZ corresponds to ST. So that is 15 centimeters. I know, it doesn't even hurt at all, does it? So angle T corresponds to Z, and Z is 47 degrees. Love it. And then XZ, where's XZ? XZ is up here, so XZ is the outer, I call these the bookends, so that's RT here, and that's not possible. All right, so your homework is not that easy, but there's some good things to think about. So letter E, I'm gonna let your homework start with letter E because this is such a good question. I don't wanna ruin it. So I want you guys to do this on a separate sheet of paper. So you're gonna start with letter E on page 145, and then you're gonna come over to page 146, and you're gonna go through questions 4 through 11. Okay, I'll have it on my CCA. Do this on a separate piece of paper. Have an amazing day. Try not to miss me too much. See you guys tomorrow. Bye-bye.